Hello and good anytime. Today we go see and learn about this other electronic component called the Zener Diode. In this tutorial, I go explain the working principles of a Zener Diode, which is used for voltage stabilization in electronic and electrical circuit. So this diode is schematic symbol. They like this one way we get them on the board right now. And this diode, na some diode way if you leave current flow through it in both directions. That is, current fit flow from the anode to the cathode as if it flow from the cathode to the anode. So when this diode be connected in the normal way as you see as we connect and so, where current dey come through this direction, for say make e conduct, the voltage across this diode for here, that's the voltage wey e must pass here for say make this diode conduct at this forward biasing direction. The voltage must be between 0.6 and 0.7 for say if you leave current pass. So when it be connected for this way, they talk say the diode be at it forward biasing. But this diode be also connected in the reverse way, and at the real way that way they connect this component in the reverse direction. So when this component be connected in that way, it means say our positive now go dey come na through this way. It means say our positive current, that's the direction for current now, it go be in this direction as we see am for here. Wey means say we will connect this side for, if to say we will go for our battery, we will connect this side for the plus side for our battery, and then this other side we connect them for the negative side for our battery. So when we connect this man for this way, na they call them the reverse direction, and so they must use it. So if for example this diode, this Schottky diode, we get a value, a voltage value for let's say 1.8 volt, and we connect a source between the terminals then. Let's say we put let's say 5 volt for here. Here na the positive side for the 5 volt, and here na the ground. And the ground is. So when we connect them for this, we connect this diode for this way, it go work like a regulator, where it means at this point for here, at this point, that's from here. So if we measure from here, if we measure the voltage across this point for here, so it will give we 1.8 volt always. Even if we increase the source voltage, even say we put 10 volt for here, we will still get 1.8 volt for here. Now why that did they say it work like a regulator? So if we use this voltage for here, we put them for inside our, normally we store them for inside capacitor, because they will always store voltage in inside capacitor, the one will go for ground. So this voltage for here, when at 1.8, if we use them for inside, if we take and save any component for inside a circuit, for example, a microprocessor, they mostly use this kind of small voltages but with very high current. So if we connect, for example, our microprocessor for here for inside a circuit, and the component when you see the shape for the component just dey like the shape for the other diodes in way we see am. That's the normal silicon diode and the Schottky diode. Where if we see am for here, if you see the component, a ray form, e dey like glass, and the glass get an orange color, where at the end for the cathode tip we get a black stripe on it. So e get two terminals too, the positive and the negative, where here na the anode and here na the cathode. Sorry, this K means cathode. So the short form for right cathode, you fit denote am like K, and then anode na like A. While ZD means Zener Diode. So now make we hear the story wey dey about this component right now. So Schottky diode na some electronic component wey e use na for stabilize voltages inside electronic and electrical circuits. That is, na some kind of diode wey dey maintain a constant voltage, and its schematic symbol dey as shown here. The pictogram of this component also get the form like the other previous diodes dem wey we don see am. Now, whenever we connect a Zener diode in the right direction or the right way as shown on the diagram, the Zener diode go function like a normal silicon diode. That is, the current go flow from the anode to the cathode. In other words, this diode dey start to flow current after when e don reach its bias voltage, wey na the 0.7 volts. On this circuit diagram, we dey see a Zener diode of 3.3 volt wey be connected in the normal way wey dey connect the normal diodes. So the Zener diode here get a Zener voltage of 3.3 volt, but if we connect it this way, the diode go start for conduct electric current after reaching its bias voltage, not the Zener voltage, because it is not used this way. When we connect it this way, it go behave like a normal diode. But in real sense, these Zener diodes are not used this way. Zener diode dem be always mounted or connected in the circuit the reverse way. We go use this diagram for really explain this. So on this other diagram, we get another Zener diode, but this time na a Zener diode wey e get a Zener voltage of 5 volt. And the diode be connected for the real way wey dey suppose to connect this Zener diode. That is, the current get for pass through the cathode for reach the anode. So after the breaking voltage, the current go begins to flow. That's the breaking voltage wey na 5 volt. And for do so, the supply voltage must be greater than wetin wey you dey want am for your output, either greater or equal to. So if e be equal, no need for regulate, so it must be greater. So when this diode be connected in the reversed way as we dey see on the diagram, the Zener diode no dey flow out current up to a certain voltage value. This voltage value, or this voltage wey e dey leave current pass, they dey call am the breakdown voltage or the Zener voltage. After this breaking voltage, then the Zener diode go start for flow current, and the voltage value on the component will always remain constant at that breaking voltage value. In fact, na some type of diode wey dey allow current for flow for the both directions, that is, from the anode to the cathode and from the cathode to the anode. And this diode dey work or dey do the job of a voltage regulator. If we look a physical appearance, their color is usually orange with a black stripe at the cathode tip as the diagram dey show here. Since Zener diode get a variety or plenty of applications in order to provide a constant reference voltage or for protection purposes, dem dey appear in many electronic circuits. So therefore, we get Zener diode in many electronic circuits that dey undertake the functions of a voltage stabilization, signal clipping, and to protect electronic elements. Now, to better understand the working principles of a Zener diode, we go see on this circuit diagram here that this resistor and the two Zener diode with their Zener diode references of 1N5231 with a Zener voltage of 5.1 volt and 1N4728 with a Zener voltage of 1.8 volt are connected in series with a 12 volt source to the circuit. And now we go use our multimeter for measure their various voltages. So always remember say this 1N means one junction. For example, the normal diode, the Schottky diode, they get one junction. So whenever you will see their references, you will ever see 1N. And we'll get 2N. 2N are for transistors because they get more than one junctions. So we'll come back for our circuit here where we'll get for our screen. So even if we increase the voltage for this circuit up to 20 volt, the measured voltage for its output will still be the same. Even if we measure the voltage across the two Zener diodes, then the total voltage will be now the sum of the first Zener diode when at 5.1 and the second Zener diode when at 3.3 volt, where we go get 8.4 volt if the connection is well done. This Zener diode be used this way since many circuit devices they operate at a certain voltages. So Zener diode go keep that voltage to the load constant and always protect the load from excess current, and always connect a series resistor in front of a Zener diode so that the diode can be protected against high current. Now we will see another example with this circuit diagram. For inside this circuit, we get three Zener diodes with three different breakdown voltages, or their Zener voltages of the first Zener na 5.2 volts, The second Zener